uBeam was born in the press, not really by choice. Just like I sort of became an entrepreneur, not really by choice.
Are you ready? All right, let's go.
Manufacturing is sexy. Sounds crazy? Just wait. I'm Z Holly, host of The Art of Manufacturing. Your behind-the-scenes look at how people who make stuff are trying to make it in their industries. If you've ever wondered how to build a brand, a business, or just a better mousetrap, tune in and enjoy. This week, Meredith Perry gives a rare interview. She's the charismatic and controversial founder of the high-tech wireless charging company uBeam. In 2011, Mark Cuban invested in her company and called it the next zillion-dollar idea. In 2015, Fortune called her brilliant and asked if she might be the next Elon Musk. But it was just less than a year later, a key employee left the company and bitterly undermined the technology. Skepticism grew, and some even made comparisons to Theranos. So, you can understand why Meredith is not someone who likes to engage with the press. Since then, her team keeps plugging away at the technology, and she's only popped her head up a couple times when it was time to demonstrate that the technology actually does work. A couple of months ago, as she was just closing a $20 million round, I came to her office bearing margaritas, because I was hoping to get her to speak candidly about her journey. And she did. I was curious about how the technology worked and her challenges along the way. She describes what it's been like to try to bounce back from her PR nightmare, and she humbly shares some of her lessons learned managing a team as a brainy, young, late-20s CEO with no prior business experience. We talk about geek chic, astrobiology, the no a-hole rule, and the struggles of trying to do something no one thinks is possible. We hear about that and a whole lot more on this week's episode of The Art of Manufacturing. Cheers.
Cheers.
On your website, you mentioned the tribe, which is so cool because I use the same term when it comes to just makers and manufacturers because we're a little different breed. So I was wondering, what was the thinking behind your using that word, the tribe?
Well, not the average 9-to-5 employee, or the average 9-to-5 employee that is clocking in and clocking out, that's, coming in for a paycheck and, just wants to have a normal life is not the kind of person that would probably not even just enjoy, but they would not survive at uBeam. So, it's a group of like-minded individuals. We all have the same core mission, and we're all here because we're driven by, we want to be part of something that has the potential to change industries. And it really takes a tribe to be able to accomplish something like that. No matter what the startup is, the road is a lot bumpier than in a large corporation or just a smooth,
that is so
easy
true.
gig.
That's never easy. Yeah. And tribe, definitely it's the supporting each other. And sometimes you almost feel like us against the world trying to get this out.
I don't like it when anybody doesn't use the term like our company or like we, because we all win. Like our philosophy is that like every single person in the company has equity because it takes literally every single one of us to win, and everyone needs to not only feel like an owner, but actually be an owner.
And I'm sure investors like that too, to see that everyone has a piece of the game. A little bit.
Yeah, I mean, I haven't really discussed that philosophy that much with them.
So what is it that you're trying to do? What's that big vision?
So the big vision for uBeam is to, well, it's expanded even further over the years, but to create a world in which we do not need wires to keep our devices charged.
But to clarify, when you say wireless too, the smartphones out there claim that they have wireless power. Why is that not good enough?
The wireless power that exists on the market today is contact-based charging, which uses some kind of magnetic, inductive or magnetic resonance coupling technology where you have to place a device in a specific location on some sort of surface that then powers the surface of that device. And if you lift your device up, it can't charge. And that's the same kind of technology that was used or has been used for decades with electric toothbrushes and also your inductive stove from like 1950. And so when you think about what makes the experience for a consumer more convenient, well, a wire versus induction, you actually have a lot more freedom. If the wire came out after induction, which it may have, it would be like, wait a second, I could pick my phone up and move it around on a cord and I can still charge. Whereas with induction, you can't even use it while it's charging. So with wireless power, when we really talk about wireless, it means you being able to use your devices in the way that you normally would without needing to think about the power draining. You can move around with them and it's charging. You don't need to be tethered to a wall. You don't need to be tethered to a table or a surface. And the power is remotely beamed to the device.
What's the basic idea behind the technology and what's been the hardest part of that?
We're using ultrasound as the medium for energy transmission. So there's two parts to the system. You have a transmitter, which beams out the energy, which you can think about like a speaker. And instead of using audible sound like a speaker would, we transmit what's called ultrasound, which is high frequency sound higher than what humans can hear, which is defined as above 20 kilohertz. We focus that sound like a laser beam so that we're able to get a high density of pressure in a small area over a large distance. That focused beam then hits a receiver, which you can kind of think about like a microphone. It vibrates this received material back and forth at a frequency way too fast for you to be able to feel. And by virtue of effectively moving this material back and forth, it generates an electrical current and then charges your device. It's not that sound itself is powering the device, but we're converting acoustic energy into electrical energy and making use of the fact that sound is invisible and can travel through the air without something physical to charge devices remotely.
Awesome. And so what's the hardest part about this?
So the hardest part about it has been in developing what's called an ultrasonic transducer. And a transducer is a device that converts one form of electricity into another. So electrical energy into sound, and it can be used as the reciprocal as well, and sound back into electricity. So it is the core component of our entire system. There's thousands of them inside of the transmitter, and they're also what make up the entire receiver as well. And so for us to be able to commercialize this system, what existed off the shelf will not work for us. Where you might find them today are really just ultrasonic sensors that would be in your motion detectors or primarily actually on the back of your car. They're your rear parking sensors. So when you back up and you hear the beep, 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 those are little ultrasonic transducers. You look in the back of your car, you'll see a little circle.
They're like little echolocators, like a bat.
Exactly. We needed to make those a lot more powerful. We needed to make them much smaller because they're huge. And we needed to make them a hell of a lot more efficient, primarily on the receive side, but also on the transmit side. And that has been an extraordinary challenge. After now 6 years of working on this, we have, and I'm actually saying this for the first time, we have hit our target efficiency on uBeam's homemade, right here in this lab, devices. And it is awesome. It is awesome. Yeah.
But I want to hear a little bit about what brought you to where you are today. Why are you an entrepreneur? How did you get here?
I didn't mean to be. I got here because I was an undergrad at the University of Pennsylvania, and Penn had an invention competition that was between the engineering school and the business school. I was actually not part of either, but that's sort of my place in the world. I don't really fit into anything. All 4 years at Penn, I just really wanted to participate in the invention competition. I'd always, throughout my life, been a part of like the science fairs and all the weird invention things.
So you're a nerd.
Total nerd. I call it geek chic.
Geek chic.
Yeah. I was trying to come up with a problem to solve so that I could create an invention for the invention competition. And I was wrapping up my laptop charger and looking at my wireless laptop and my 15-foot wire dangling from it and thinking, well, this is really stupid. How can we get rid of this thing? How can we beam energy through the air so that we don't need a wire to charge it? And actually came up with the general system architecture within the first 48 hours of asking that question, which is actually the same that it is today.
That's wild.
but it just took a long time to execute.
That's pretty crazy.
Yeah.
What made you interested in science in the first place?
I think, what some may call aggressively curious or intensely curious about most things, but mostly things that have to do with how things work. And I find it endlessly fascinating.
What's inspired you to be a geek chic?
Yeah, I mean, okay, well, I will ask questions until people will stop answering them. And growing up, my dad had an endless supply of answers. And so I would ask literally endless questions about anything that I would see. I was like the most annoying kid on the planet. Like, I would be like, why and how and this and that. And I'd look outside and I'd be like, well, why is there grass there? And why is there this? And pretty much until the answers would stop, which was rare.
Did he actually answer them correctly, or you think he made some stuff up?
He answered most of them correctly, unless he was kidding and I didn't realize it, which did come back to bite me a few times.
Like what?
When he convinced me that the word crap came from the inventor of the flush toilet named Henry Crapper.
And that's not true? That's what everyone says.
Oh, really?
Yes.
I mean...
I think it was Thomas Crapper.
Also,
I don't know.
He told me that, like, one of my great-grandparents invented the bathtub, which I'm pretty sure is not... No, I'm definitely sure is not true. But he liked it to kid around with some weird stuff.
My dad did too.
Yeah.
So fortunately, your dad kind of dignified your crazy questions with lots of answers.
Yes.
You kept asking questions.
Yeah.
And then what was your major?
Well, I tried to make my own major called astrobiology, but I could not get Penn's approval because I needed the approval of like 3 different schools. My major was technically paleobiology. I did my thesis in astrobiology, and I did astrobiology research for the remaining 2 years that I was at Penn with NASA and Penn together.
Mm-hmm. Very cool.
Yeah, it was fun.
What were you studying in astrobiology? What was it that you were trying to figure out?
Well, my personal interests with astrobiology were a little bit different from what I was actually studying, because the questions that I was trying to answer were a little bit difficult to get grants for.
Yeah, so what were they?
Well, one of my first professors at Penn, he was an astrobiologist. His name was Professor Lead Wells. He really opened my eyes up to the difficulty of looking for something when you don't know what you're looking for. Mm-hmm. Anyway, so the whole point of that is that if you can't define what life is and you're going to go look for it, what are you looking for if you don't know what you're looking for? And how do we think about things that are foreign to us? So I studied a few different things, but primarily I was looking at about 2 billion-year-old stromatolites, which is a fossilized layer cake of ancient cyanobacteria, which is just blue-green algae, on Earth, particularly in the Mojave Desert around here. The reason for that was because stromatolites are the earliest evidence of life on Earth today. And about 2 billion years ago on Earth, Earth's atmosphere and environment was very similar to that of Mars 2 billion years ago. And so the theory was that, well, if Mars and Earth had similar environments, and if cyanobacteria was able to grow on Earth, is it possible that we would be able to find evidence of stromatolites and cyanobacteria on Mars? It was actually really cool because I had read this paper from like 1960 or 70 or something about these specific stromatolites, these Precambrian stromatolites in the Mojave Desert, and all we had were the coordinates. And we found the exact stromatolites just based on the coordinates. And I ended up getting like hypothermia on the top there. Because I was like, oh, I'm going to the desert. It's going to be so hot. It was. But then, the climate's there.
Whoops.
And, yeah. So I had to like run around the mountain like 4 times.
I'm curious about how you're finding the right market for your technology, because the technology can be used for all sorts of different powering applications.
Yep.
So have you changed that plan at all?
Not really. Mm-hmm. We started the company thinking about consumer electronics devices, and our first markets will be consumer electronic devices. We've been introduced to many more markets than I would have imagined would find this technology useful along the way, but I still think that the path that we're going down is the right one, and mostly just because it's been validated by the market. I would switch to whatever we needed to if there were a problem in another market that was large enough for us to attack if it presented itself. And some of those have, like, in the medical world and in the industrial world, but those markets also take a lot longer. And as a startup for whatever product that you're trying to get out first, to wait like 5 years for like FDA approval or however long it would take is just simply too long for us to be able to do. I mean, you could do it in parallel, but you can't count on that as your first market.
I mean, clearly the idea of being able to just walk around your house with your device and not have to worry about charging it, that's completely compelling to a consumer, and I think we would get it. But then at the same time, technically it's a lot harder because then you have to be, following it around. So wouldn't it make more sense to try to approach an application where maybe like IoT, where you have very fixed devices that are harder to charge, actually, because you can charge a cell phone just by plugging it in.
Right.
It's a lot harder to charge something that's maybe, if you had 100 devices throughout an industrial application, let's say.
IoT and things like that, I consider that consumer as well. Well, there's industrial IoT, like in a factory, and then there's, IoT as in like the smart home. And that's something that we're actively working on as well. And that is a great place for us to start. But for something like that, the end user might not even know that wireless power is a part of it. It might not be a feature. It could just be, hey, stick these on your walls and forget about them forever.
Yeah. How do you actually use this to power stuff all around your house? My assumption was that air is not as conductive to sound up in the ultrasound, right? So that makes 100%. It a lot harder. So tell us, like, how does sound work?
Yeah.
And how does this actually work?
Air and sound. Yeah, they don't go well together, which might seem a little strange since that's what we're doing. But we're using ultrasound as the energy of choice because we firmly believe that it's the only type of power that can be sent in large enough quantities over large enough distance while staying safe within regulatory limits and without interference with any kind of communication system or electronic devices.
When it comes to electromagnetic spectrum, the FCC has the control over when it's really powerful, and then when it's weaker, then a lot of the devices in the home are already using that technology.
Yeah, and so if you were to use something on the electromagnetic spectrum, like radio frequency, RF, or anything else on the spectrum, you're going to be limited in terms of how much power you're legally able to send. And then you also have a safety issue along with that in terms of, your SAR limits, the absorption rate of how much radiation people are allowed to absorb. So, and then on top of that, and this goes for any type of energy that you're transmitting through the air, what size transmitter and what size receivers will it require for you to send the same amount of power over that same distance? And so when it comes to all of those questions across the board, ultrasound is able to transmit the largest amount of power over the greatest distance to the greatest number of devices with the smallest transmitters, smallest receivers.
Really?
Yes.
That surprises me, actually.
Without any of the issues that we discussed before of regulatory safety or interference. And while air may be a crappy medium, it's the only thing that will work in a commercial space.
Can you show me how it works?
Yes, I can.
Okay, cool.
Okay. So we're going to turn the transmitter on. Anyway, so sound is literally vibration of media, whether that is air, particles, or water, or something solid. When we're transmitting sound through the air, we're vibrating air particles back and forth. So we're supplying a force. So it's almost like programmed wind in a sense. So you then have these cascading air particles moving through the air. They hit your ear and they wiggle these tiny little hairs in your ear. And the movement of those little hairs in your ear then sends a signal to your brain that you're hearing something. This whole phenomenon of this thing that we understand as sound in our brain is not actually what is happening in the outside of our heads. It's our brain's interpretation of this change of state of matter and energy. You can manipulate sound or the air particles very precisely in such a way that you can actually force them to converge at specific points in space so that you can effectively funnel them across a room.
So you're using kind of like an acoustical lens of sorts?
Yeah. So the best way to think about sound is to compare it to things that you can see, like light and water, because most waves behave in similar ways. This really is the sound analog to a laser, what we've created. What we're doing is we are changing the phase and amplitude of each wave of sound that we send out. Okay, so you can compare that to ocean waves. Mm-hmm. So if you're in the ocean and you see two different waves coming at each other and they're about the same size and they're moving at about the same pace and they hit each other at the right angle, they're going to form together and form one bigger wave. Mm-hmm. And that's called constructive interference. And so instead of spreading that energy out and getting all these little waves that are going outwards, you get one larger wave that is heading in one direction. And that's what we're doing with the sound waves. So we do that digitally. It is an array of little speakers. You can control independently every single one of those tiny little speakers such that the waves are transmitted from each and every one of them at specific times and in a specific frequency and in a specific phase, such that they will all collide together at a specific point in space, which happens to be exactly where the device that you want to charge is. And so we constructively interfere those waves, and you get this massive pressure hit, just like a big ocean wave crashing against the sand right on your receiver. And that's where, when you're hitting this receiver over and over again, 40,000 times a second, because we're using approximately 40 kilohertz sound, then the receiver is being stressed almost continuously, 40,000 times a second, and we convert that pressure into
power.
Yeah, I'm sorry.
We're looking at an array of tiny little speakers. Can't really see it. You can see little dots, and it's on a desk.
Right.
And you're holding up a phone.
So we've got a transmitter, again, with the array of transducers or little speakers. And we also have a vision system. Mm-hmm. And the vision system is looking for devices around this room. When it spots a device, it then tells the brain of the system, okay, we've got a device over here, and it requires this much power, it's this size, it's this distance away from the transmitter, it's at this angle from the transmitter, and we then have beamforming algorithms inside of the transmitter that say, okay, well, based on the location, orientation, size, and power requirements of all of these devices around the room, I'm going to form multiple beams that are of different size and different shape and send those different beams to each different device. So if you could see it, it would kind of look like a laser light show, except you're updating it continuously, because as those devices are moving around a space, the profile of that beam has to change as well. And it also intelligently optimizes which elements or transducers of the phased array it should be using based on where the device is relative to the transmitter.
Got it.
And so it splits the array.
Sorry for asking the dumb question, but I'm sure a lot of people ask this question, is ultrasound.
Yes.
How do your pets feel?
No, it's not a dumb question at all.
Yeah.
If you walk around this office after we leave this room, you will notice that we're very dog friendly and pet friendly, and we've got animals running all over. Not really by design. I just let people do whatever they want. We actually had a very serious technical review yesterday. We brought in our technical advisory board, and the chairman was a former dean of engineering at the University of Washington. We had literally 4 dogs running around this room. It was like, oh my God, maybe this is a little too much. I think he was like, what is going on here?
Okay, but it shows that at least what you're doing in here is not hurting the dogs.
Yes. So even if you can perceive the frequency of sound, you may not be able to hear it. Even when we have our prototype systems that are continuously just transmitting power, even though that's not how the actual product works, we have not had any issues yet. And we've also been doing major third-party unbiased health and safety studies for people, animals, everything in between.
You're listening to The Art of Manufacturing. Follow our adventures on Instagram and Twitter @ArtofMFG. And to chat with other like-minded creators, join the Art of Manufacturing Facebook group. We'll be right back after this break. The Art of Manufacturing podcast is a collaboration with Make It in LA, which is generously supported by organizations like the LA Cleantech Incubator. LACI has a really cool facility in the Arts District of downtown LA filled with energetic startups and nonprofits. They offer cleantech startups flexible office space, epic prototyping labs, and the #1 rated cleantech incubation program in the world. Learn more at makeitinla.org/LACI. We're speaking with Meredith Perry, the founder of uBeam. Where would you put the chances that this is actually going to work?
I'd put it pretty darn high. Otherwise, I wouldn't be here.
Yeah.
Otherwise, it's way too hard.
That's that self-delusion, that entrepreneurial self-delusion that we all put ourselves into, isn't it?
No, because, we've had a pretty rough journey. And I'm either completely out of my mind or I know how valuable this thing is and can be in society and have been willing to stick it out to see it through. Mm-hmm. And I'm betting on the latter. Although some may think that I'm completely nutso.
I know.
Yeah. I mean, it would be very easy to leave. But when you have some of the largest companies in the entire world, and not just the largest like consumer electronics companies, the largest companies in the entire world telling you that your solution is likely the category winner for wireless power and that their biggest problem for industry X is wireless power, and you can meet their specs, I think you've got your product market fit. Yeah.
But you've had a challenging road, definitely.
For sure.
Can you just tell a little bit? I mean, people are going to be curious. Like, you had a VP of engineering leave. You had some, disgruntled folks that said this is never going to work. And then it discredited you and you decided to just not deal with it. Can you tell us a little bit about that experience and how did you react to that?
Well, it felt like really good. I'm just kidding. When you have someone out there that is trying to destroy your company and your reputation, and somebody that has or should have a lot of credibility based on, the few letters next to their name, like a PhD and when they've got an axe to grind and they say something like that, your company's a scam and your product is vaporware and you're exaggerating all of your blah, 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 whatever it is, it's extraordinarily difficult. I mean, the truth is that like at the end of the day, like we are just a bunch of nerds and or geek chic people that are just trying to make something cool happen. And, we're not trying to hurt anybody. And we're working our butts off on a solution that we know is going to be beneficial in the world. It's already hard enough. And so to have another layer thrown on top of that, where you've got people that are not just not rooting for you, but are actively trying to take you down and strip your credibility from you, when the only thing that you have is your integrity, especially as, a first time, me personally, a first time founder with no history, it just makes it like 1,000 times harder. It's harder to recruit. It's harder to raise money. It's harder to do everything because you have to battle against this awful perception that someone else has thrown in your way. And so the reason why I chose to do quote unquote nothing was because I thought that my words ultimately mean a lot less than what's measurable, which is the technology itself. And I have always said at the end of the day, people can say whatever the hell they want, because we started in a place where even, my own physics professors at Penn told me, this is breaking the laws of physics.
And is that because it's hard to be pushing so much power through ultrasound, or what was breaking the laws of physics?
It was really just, in the early days, asking around anyone that would listen to me that knew something about electrical engineering or physics, saying like, hey, well, do you think it's possible to be able to make something that could do X, Y, and Z? Or do you think that we would be able to do ultimately ultrasonic wireless power transmission to charge things like cell phones? And the answer was more often than not, no. But then when you would break down the problem and say, well, could I make a transducer that could output like 150 decibels of pressure? Could I make an array of those things and beamform them in such a way that I could avoid a lot of like the issues of nonlinearities? Could I do blah, 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 blah? And, so all of these problems, there was not a single problem when we broke the main question down that couldn't be addressed. And my big fear in those early days that like one of these days, like one of those problems just, I'm going to be stumped and we're not going to be able to find a solution for it. And
I guess if it were easy and obvious, it would have been done already.
That's what they say. As I've learned along the way, because you develop some pretty thick skin if you're going to be in a world where most people are pushing back on you. Most revolutionary technologies in the world were considered crazy up until the point that they became revolutionary. I mean, so many of these, scientific heroes that we look at today were, shunned from society and thought of as crazy, and they must have lead poisoning, or they must, blah, 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 for their theories of evolution or their theories of
heliocentricity.
I mean, all of these things, or I mean, even things simpler like different methods of transportation, like going on a train. People said before trains were created that if you would go on a train, there's no way that humans would be able to look out the window and see things moving so fast without continuously being nauseated and vomiting everywhere. Or that, electricity could never be tamed. There's literally endless examples of naysayers because it's a lot easier to say no than it is to explore the possibility of something happening.
So how much money has it cost your investors to explore this possibility?
Well, if I'm answering that honestly, then exploring the possibility took a different amount of money than how much we've actually raised, because we had proven it a long time ago. And to be precise, it was December 5th, 2016 that we first charged a phone in the air.
I remember I saw it on stage.
No, that was February 2nd.
Oh, right. And last year.
Yes. But the first time I saw it.
Right.
Yeah, my legs were shaking like.
But you haven't really announced it. So what's up with your PR strategy?
That's a good question. Well, actually, so PR strategy. uBeam was born in the press, not really by choice. Just like I sort of became an entrepreneur, not really by choice. I created this weird thing for an invention competition, and people got interested in it, and then I formalized it by making a company around it, and then all of a sudden I'm a CEO and a founder, and I'm introduced to this whole Silicon Valley world, and like I'm thrown into this whole startup thing when I'd never thought about it before in my life. So like a lot of people like go out there and they're like, I want to be Mark Zuckerberg, and I want to, and I want to start a company, and then I want to get acquired by Google and sell it for, $40 million and blah, blah, blah. But that's not at all what I was thinking. Anyway, so we were born in the press through what used to be Walt Mossberg's All Things D conference and Kara Swisher. But if I were to do it all again today, I wouldn't have had any press ever. Mm-hmm. It's just unnecessary. It's a major distraction, both positive and negative. Mm-hmm. I mean, of course there are trade-offs where you have positives and negatives. Mm-hmm. It depends on what kind of business you are, first of all. Like, if we were a consumer brand that was trying to sell specific items to end consumers, then yes, like you should be all over the place marketing, and usually those with the most money that can market to the most people can win. But if you're a technology company and there's no action for the end consumer, then what is it that you're selling to people? And so it's sort of just a waste of time. Mm-hmm. I mean, for recruiting purposes, maybe, but
that's an important part, though. Recruiting.
Yeah, no, it's a hugely important part. But at the same time, what happened to us was, we had so much press, and because we had so much press, then it was an interesting story when, ex disgruntled employee leaves and has a fit.
And it wouldn't even have registered.
Right. It would be like, all right, if we didn't have any press, then it'd be like random company,
right,
that no one's ever heard of.
But now all of a sudden you're compared to Theranos.
Right. When the only thing that's similar between the two companies is that both the founders happen to have 2 X chromosomes and blonde hair.
How did you recruit your VP of engineering?
That guy?
A new one.
Oh, new ones?
New one. Because you're up against some challenges there at that point.
Yeah. So one of my favorite stories is after all that terrible press, I contacted a whole bunch of the loud voices that were critical of the company and invited them to the lab. One of those voices, his name was Dr. Matt O'Donnell from the University of Washington. He was the former dean of engineering and one of the world's most renowned names in ultrasound. And he was incredibly skeptical. And so I said, just, come by. And I told the entire team, just go open kimono with this guy. You're going to spend the entire day with him. I want you to show him everything. And he left as the chairman of our technical advisory board because I knew there wasn't a chance that someone could step foot inside of this building where we make, model, build, simulate, and test everything, that someone could leave thinking that we were anything but real. And so we have never had somebody enter this office and leave skeptical. And that's how we recruit. It's harder than putting up an ad. But that is the greatest thing about science and engineering, in that it is measurable. You can debate anything till the end of time. And at the end of the day, if something is scientifically true and factually true, you should be able to repeat that and measure it. I mean, it's the ultimate argument.
What was the biggest surprise through the whole process?
That people, not technology, would be the hardest challenge in every possible way. Engineering is predictable and people are not. And so
people are just nonlinear all around.
Yes. Yeah. And
so what have you learned through the process then? How are you doing things differently now than you did 6 years ago with people?
I follow the no a-hole rule, where I don't hire those kinds of people, no matter how smart they are. Where my rule used to be that I would only bring in the absolute smartest people that existed on the planet, no matter their personality flaws, because I felt that only those people could tackle this problem because it's so hard. But it is true that if you bring in someone that's toxic, that will spread through your company. And it is not worth the positive trade-off of whatever intelligence they bring. I do a lot of things differently. I've also grown a lot. I'm having never had a real job before, other than interning at NASA and doing space research, which really felt just more like academia. I learned literally everything by the seat of my pants and have made almost every mistake in the book.
What's one of the mistakes that you made?
I mean, name the issue. Like what I just said in terms of hiring. I also think that when you're young, and this is not being ageist, but really more of a natural phenomenon, when you hire, your big shiny execs that are, at least twice your age, no matter what your gender, you may likely have a dynamic with those people that isn't one that you want. I think it is hard for people that have like 20 more years of experience than you, who've been doing something for a really long time, if they disagree with you, to not try and think like, oh, this stupid kid. Like, why isn't it that I'm running the company again?
Are you resigned to only hiring people that are younger than you?
No, absolutely not. In fact, I'm one of the youngest people in the company by far.
So what is that like?
It's challenging at times.
Yeah.
But we have a very good team now. I'm very, very selective about who we bring on.
You're pretty authentic, and you're yourself, and you're not afraid to be yourself. And I say this lovingly, like kind of rough around the edges. People know like where they stand with you, I think. And I'm wondering how that's impacted the way you've led. You've been a leader. Has that changed? Are you still that way? Have you felt like it's been challenging to stay authentic to yourself?
Authentic to myself is the only thing that I can be. I don't like to waste time. And so sometimes when you are trying to be as efficient as possible, you can come off as terse and perhaps rough around the edges. With me as a new leader, one of the things that I had to learn along the way was, not to tell people what to do, but the importance of getting buy-in from people and making sure that people aren't just like hearing what you want, but they understand it and also agree with it, and learning the difference between intent versus impact. If the impact doesn't match your intent, then you must change your behavior. And these are all like probably like management 101 type of things.
What's an example though?
I guess one example in a meeting that I had with one of my favorite people in the world, and also one of the smartest people I've ever met, who's also, a technical leader here. He's so smart that he thinks so much faster than he speaks. And so when he does speak to a large group of people, in his head, I think he skips over a lot of sentences. So it's almost like if you were to if you were to start reading a book and you found yourself in the middle of the book, but you never got to read the beginning and you have no idea what the book is even about. And so I would constantly interrupt him while he was, giving a presentation or something like that, because I would notice that people were a little bit lost because they were like, wait, what is it that we're talking about again? I need context here. I need, what do you mean by that? And then I felt horrible when I was really trying to help the situation, but it just came out in the wrong way, where it almost was like I was critiquing every single second. And I felt so bad. So that's one example of intent versus impact going awry.
Have you had any mentors, and are your board members and your investors, have they been helpful in this since you are a new CEO? VCs aren't always known for being always friendly to the CEO. They care about their portfolio.
Sure. I mean, it is their job at the end of the day. I've had a couple people that have mentored me. One of them is on my board. Her name is Katie McMahon. She is general manager at a company called SoundHound. And she's helped me from day one, literally day one. I met her at the D conference. She's been an amazing voice to bounce ideas off of. And then I also have an advisor, Martine Rothblatt, and she's the single most inspiring person that I've ever been around. She's faced endless challenges across so many different dimensions of both life and engineering and science. And whenever I have any kind of technical challenge, talking to her is like the best boost that any person could. I feel so lucky to have.
Amazing.
Yeah, I just said, like, Martine, listen, like, I need you to be part of this. And she said, Meredith, I say no to literally everybody, but I will do it for you. And I'm extremely grateful. Like, there's genuinely nobody who inspires me more, living or dead.
Wow.
Yeah.
Who's your third advisor?
Ken Hertz.
Oh, yeah.
And he's an incredible guy. He's honestly one of the most creative people I've ever met. Mm-hmm. I mean, he has his hands in so many things. I just don't even understand how that person operates. So it's Martine, it's Ken, and then Matt O'Donnell, who's the Dean Emeritus of Engineering at the University of Washington. And we added one more, Chuck Davis.
I remember when you were going through some real tough times with the sort of media dust up, which is saying it lightly. Mark Suster, one of your investors, really stuck his neck out.
Oh, yeah. It helps that he's like down the street, literally. And one example of just like how supportive he is and just of who he is as a person is Mark came to everybody's first day of work and gave this whole speech about why he supporting uBeam and why he believes in the company and in me. And, awesome. And he gave everybody individually his cell phone number and his email address and told them that they were open to call him anytime.
Like, if Meredith isn't holding up her end of the bargain, give me a tip.
Yeah.
Where are you manufacturing this? You're not there yet. So what's the next step?
Right here.
Yeah. What is the next step? When are you going to be ready to scale this? And is this going to be total partnership, or are you going to be manufacturing it yourself?
We will always make onesie twosies, as we call them. So in this lab here, we build...
In Santa Monica.
In Santa Monica. We build all of the core components of the system. Of course, we get like our boards like fabbed elsewhere and things like that. But we assemble everything here and everything like that. And we make thousands of transducers here, but not for sale, for building devices. And our business model is more similar to that of like Qualcomm or Intel, where we will actually physically build devices and make reference products or reference designs. And we have all the IP around the technology and in those designs. And we can physically give those the full product to the OEMs, the consumer electronics companies, and they license the IP from us. And, we basically, in your reference design, it's been fully tested like a product. It's been fully spec'd out. You have, the steps and the ingredients and the manufacturer lined up that knows the entire fabrication process and manufacturing process for the whole thing. And then, they then take care of the supply chain and the rest of the manufacturing, the rest of the value chain after licensing the technology. But we work with the company to make sure that the product is engineered and works with their technology quite well.
Do you have any licensees yet?
That I can't say.
Okay. I didn't think you were going to be able to answer that. What are you the most excited about going forward? Kind of what trends, either trends in the industry or where you want to take this company beyond what's obvious?
uBeam has a very interesting opportunity for a few reasons. One, since we fundamentally believe that it is the only type of wireless power that will be able to operate in a meaningful way over long distances through air for consumers. And because we have all of the IP around it, if we're right on that, then we will be the company to solve the wireless power problem for people. And if we're able to send power to all of those devices and get into those devices, you have the ability to communicate with those devices. You have the ability to gather data around not just those devices, but the environment within it, not in a creepy way, but in ways that could impact positively many different things moving forward. And one example of that would be like if you know precisely what devices are using how much power at what times and what spaces, then all of that data could be used by the energy utility companies to ultimately smooth out the grid and lower the cost of electricity. I mean that's a huge vision and a long time, but it's that kind of stuff where that kind of big data can play an enormous role. And so ultimately, when we think about the future of uBeam and the role that it will play in society, we think about it in that it will hopefully become like the nervous system for every room that communicates with devices, that powers devices, that is aware, that can audibly speak, that can listen, that is connected to the cloud, that can do anything that your sensors would do. Well, I can't say anything, but a lot of things that your sensors could do, because it's basically just made up of thousands of tiny, very sensitive sensors all in one box with just a change of software. So cool. There's some cool stuff.
Tell me about your 16-year-old self and what would she think about you now?
16. Okay, so I guess I was a junior in high school. I was living in Princeton, New Jersey with a lot of basset hounds and my family. And I think I was going through my Richard Dawkins phase.
What did you want to be when you grew up?
An astronaut.
Why didn't you?
Well, there's still time. Who says I'm grown up? Yeah, I mean, that's partly why I pursued astrobiology. I wasn't going to be an astronaut like I wouldn't say the old-fashioned way. I don't know if there's an old-fashioned way, but by being a test pilot and,
Well, there are two ways. It's the pilot. And
then there's like the doctor.
Yeah.
And so I was thinking about those other routes, and I thought that my skills in astrobiology would be a unique value add, but whatever. By the time I even have time to go to space, we'll probably all be going there, so we won't have to have a name for it.
What were your friends like? Were you a nerd, no friends, or did you have...
I have always been just weird old me. I've always had a lot of friends, and I've always had a lot of friends with a lot of different interests. So bringing them together was always weird.
Oh my God, that sounds like me too.
Yeah.
None of my friends knew each other or liked each other. They're all different.
Yes. I have the super, virtuosic music friends, and then my hyper intellectual friends that I would like just talk to about physics and string theory. And then, my friends who were like comedians and rappers and, blending those kinds of things together is odd. Most people don't blend that well. And so that would only really happen at like birthday parties and stuff. But yeah, I mean, like I've always thought that being smart was cool. And I've always thought that science was super cool. And so not fitting in or any of that kind of stuff was never, ever something that I gave a crap about. And I think I did fit in because I think half of being cool is just about being confident,
Yeah, it's true. What's the one piece of advice you wish you had when you started your company and you wanted to share with other entrepreneurs?
Can it be 15 things? Try not to take other people's advice. Because as the founder, you are the one person with the full data set on every single aspect of your company, all of the levers, all of the little dominoes that will fall with every decision that you make. And anybody else that you ask will only have a sliver of that data set. And so you ultimately will be the one to make the best decision for your company. And I've made a lot of bad decisions in the past listening to other people's advice. But it's also important to, not listening to advice, but taking. It's important to listen to other people's advice and to learn from other people's mistakes. But ultimately, it's your job to combine all of that intelligence together with the data set that only you have and make the best decision moving forward. And it is super lame and a cliche, but a cliche for a reason, and that you should trust your gut because it's usually right.
What's one example of your taking bad advice?
That's confidential.
I'm sure there's plenty that's confidential. Is there one that's like not as confidential?
Anything that had to do with operating out of fear has always been the wrong advice. I can't say the word always because I would have to think about every single condition. But at least for me, it has always been the wrong decision.
How can people learn more?
So you can check out ubeam.com. You can, if you're a physicist or an electrical engineer or a mechanical engineer or an acoustics engineer, you can apply to work with uBeam.
Only steps to the beach.
We are steps to the beach. Come work on this epic power revolution with us.
Nice.
And don't believe what you read.
It's been really great chatting. Loved having the margaritas with you.
Yeah.
Hanging out, learning about your journey. Definitely the entrepreneurial journey is not always easy.
Nope.
But
it will be worth it in the end, for sure.
I'm excited for you.
Yeah, me too. Thank you.
Thank you. Learning about the technology and seeing it working was really pretty cool. In the demo, Meredith stood in front of one transducer array and held up and moved around another smaller array with LEDs on it that would light up and show where the acoustic power was going. And she also did that with a phone with a transducer array on it. And although I don't know what the efficiency of the system is, the phone actually charged as we moved it around. I'm still not completely sure why she's focusing on the consumer side, since I think the expectations and the technical requirements are a lot higher than if she were focusing on industrial applications. But it must feel great for her to demonstrate that the technology is finally working. 3 more things stuck out at me. So first, it's sobering to see Meredith go through such an extreme entrepreneurial roller coaster. I mean, it's hard enough for anyone to be an entrepreneur and to take on a big challenge like a startup that no one's done before. But I can't imagine what it would feel like to have your integrity questioned on such a public stage. Her tenacity is impressive. And so I understand her reluctance to stay out of the limelight while they still do their development. There's maybe not a purpose to be out there in the media. But at the same time, I wonder whether she might have benefited from some more proactive PR. Second, her comment about not taking advice really resonated with me. It sounds counterintuitive, but as an entrepreneur, you are the only one who cares the most and knows the most about your product and about your company. It's incredible how many people will give you advice as though they have all the answers when in fact, confidence has little to no correlation with someone's actual knowledge. It's so important to listen to input from people you respect, but ultimately it's up to you to take the input and take ownership of the decisions. I suspect that she's learned that the hard way early on. And finally, I was actually surprised by her candor once we started talking. I can totally relate to that feeling, which I've struggled with over the years, figuring out how to be yourself while doing what's right for the organization. Meredith's Achilles heel might actually be her strongest and most charming attribute at the same time, if she figures out how to harness that authenticity. I can tell she's not one for politics or too much diplomacy. It means you know exactly where you stand with her. But it doesn't serve her well when working in a political world. She's been learning fast, and I hope she's learning fast enough. Time to wrap it up for The Art of Manufacturing. Tune in next Thursday when we have a discussion with 4 experienced entrepreneurs about whether to manufacture locally. One more reminder, this is your last chance to help us out and vote for Maker Walk in the LA 2050 Challenge, closing Friday, June 29th, 5 p.m. Pacific. If you haven't done so yet, please go to makeitinla.org/vote to learn more and to cast your vote for us. That is makeitinla.org/vote. Thank you so much. For show notes, visit www.artofmfg.com. Follow our adventures on Instagram and Twitter at artofmfg. And to chat with other like-minded creators, join the Art of Manufacturing Facebook group. Never miss an episode. Subscribe on iTunes or Spotify or your favorite player. And if you like the show, do us a favor and leave us a review. Or send us a message with your thoughts and ideas to feedback@artofmfg.com. This podcast is produced by At Large and Dangerous in collaboration with Make It in LA and other partners. Visit makeitinla.org/connect to sign up for local LA events and news. A big shout out to Peter Brandenburg, the producer and audio engineer. Thanks for listening to The Art of Manufacturing. I'm Z Holly, and remember, don't just make it, make it.
What do you think? Stronger? Weaker?
It's good.